Okay. Okay. All right, so 1 and 2-step equations. This is a review lesson. It's a skill that you should have came to pre-algebra with. Chromebooks when you put away. So parts of the equation. We talked about this week. The 15, the number in front of the x is called the what? The coefficient. And the x is called a variable. And the number is called the constant. Good job. Okay, so an equation versus what we've been doing. What we've been doing, distributing, combining like terms, those were expressions. And they were expressions because they were not with an equal sign. Okay? So expressions were not equal to anything, they just were another expression. Equations have an equal sign where x actually has a value assigned to it. Okay, so expressions, you did not solve them, they just said to simplify. Equations have an equal sign, therefore you can solve them. Does everybody understand the difference there? Okay, so to solve a one-step equation, our whole goal is to isolate. What's isolate mean? Get it by itself. Isolate the variable by using inverse or opposite operations. So what operation is the opposite of addition? What's the opposite of division? Multiplication. What's the opposite of subtraction? Adding. What's the opposite of multiplication? Right. And in math, how do you know something's multiplication? Like if you look at that 15x plus 4 equals 60, which one of those is multiplication, Ryan? The 15x, because when a number is up against a variable, there's no operation between them. So we assume that that is multiplication. Okay, so with two-step equations, you're always going to undo the addition or the subtraction first, and that removes the constant. So I always want to undo the addition or subtraction first. After I undo the addition or subtraction, I undo the multiplication or division. And that multiplication or division will come from here, which removes the coefficient. So like if I was solving that one up there, I would first subtract the 4 since it's an add 4. Then I would divide by the 15 because it's multiplied by 15, and that would get that x by itself. And a tip, and the math 7 kids don't understand this for whatever reason. When you divide fractions, what's the rule for dividing fractions, Aaron? Thanks, Aaron. Heat, change, flip, right? So when you divide fractions, you end up multiplying by the flip. What's another word for the flip? Reciprocal. So you end up multiplying by the reciprocal. So a shortcut when solving equations is if you have a fraction as the coefficient, you can multiply by the reciprocal to clear that. So if you don't know what reciprocal is, you can put underneath of it the flip of the fraction. No matter how many times we've gone over it with math 7, it's like mind blowing.
It doesn't exist. It's just going to come on the page.
All right, so we're going to quickly go through a few of these since it is review. We're not going to spend a whole lot of time on it. I'm going to kind of pick and choose what we do. All right, so number 1, x over 1.5 is equal to 16. What operation is that fraction line? Division. So that's actually x divided by 1.5. So the opposite of dividing by 1.5 is to multiply by 1.5. Now, I'm telling you, I know that you could probably do some of these in your head. However, if you do not show your work, what is going to happen? No.
Zero.
Trash can and a 0. So if you do not show your work and you only write answers down, I will take your paper and just throw it like that. And I'm not kidding. I did it all in Math 7 when we did this. So is that very clear to my people in here that refuse to show work? But that's what's gonna happen. Okay. All right, so 1.5 divided by 1.5 cancel out, which gets my x by itself. And then 16 times 1.5 is 21. Yeah, I was like, because I was doing 16 times 3 halves, so 3 halves out of 2 is 8, and then 8 times 3 is 24. Yeah.
What I did was I divided 16 by 1/2, got the 8, and just added 16. And just kept it. I got the same answer.
I know, but all right, let's look at number 3 here. Number 3. This is 6/7. What operation between the 6/7 and the e? Multiplication. So that's 6/7 times e equals 12. So I know that we said the opposite of multiplying is dividing. So you could divide by 6/7 here, but we said when we divide fractions, we actually end up multiplying by the reciprocal. So the shortcut with these is that if your coefficient is a fraction, like 6/7, the shortcut is to multiply by the reciprocal, which is 7/6. And with an equation, whatever I'm doing on one side, I'm doing the exact same to the other side. And look, these 7s reduce out, these 6s reduce out, which is what I wanted to happen, so my e's by itself. And then you can just use your calculator or whatever, but 12 times 7/6 is 14. ABC button. But you don't need to calculate for this, because look, what's 12 divided by 6? 2, and what's 2 times 7? That's where it came from. All right. Okay, number 4. That's a G. A G is in goat. G plus 3 1/2 equals 10. Okay, what would I do to get the G by itself, Trevor? The 3 1/2. Okay, so we're going to subtract the 3 1/2 because it's a plus 3 1/2. So subtract 3 1/2, subtract 3 1/2. So 3 1/2 minus 3 1/2 is 0. So I'm left with G. And then 10 minus 3 1/2, half makes that 4. So that makes 6 1/2. You can put 6.5. I'm totally fine with that. What's the only answer that I'm not going to accept? Nope. Repeating decimals are not an answer. Repeating decimals need to be given as a fraction. Other than that, I don't care if it's a decimal or a fraction or a mixed number. All right, number 6. I need to get M by itself. Taryn? Okay, so we're going to go with Taryn says, hold on, wait a second. I want to prove something here. All right, so Taryn says we're going to subtract 6, and this is a very common mistake. What is negative 6 minus 6? Negative 12, which is not 0. So that's why I can't do that opposite operation, because it doesn't cancel out. So what is the opposite of negative 6? Positive 6, so I should actually add 6. And what is negative 6 plus 6? 0, so those cancel out. So that leaves me with M equals 3.6 plus 6 is 9.6. Yeah. So, Taryn, that's a very common mistake. I'm seeing it all over the place, and I've been doing these this year. But always ask yourself, do they cancel each other out? So, like here, positive 3 halves minus 3 halves is 0.
Excuse me, teachers. 6th grade teachers, we are ready for you to walk your students to the gym for the presentation. Elected teachers, please relieve the 6th grade orange team when this class is over. Thank you.
So make sure that you're asking yourself, are they canceling each other out? Are they true opposites of each other? Franklin, what's your question? All right, number 7. These are a little goofy, but these are called algebra tiles. So basically you just kind of put them together. So this right here, this is a negative 1x and a negative 1x. So what does that make right there? Negative 2x. And then over here, this is negative 1 plus 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 negative 1, which is negative 6. Okay, so they're just giving it to you as algebra tiles, and they want you to write it as an equation. So I'm going to come over here and put that that's negative 2x equals negative 6. And then what would I do to solve this one for x? Right? Divide both sides by negative 2. And I know that I'm supposed to divide here because there's no operation between the number and the x. So I'm going to divide by negative 2. So x equals 3. Now, every year I have a certain group of kids that are like, well, Miss Wilson, that was a negative 2, so shouldn't I add 2? When I'm talking about operations here, I'm talking about operations that are between the number and the x. So, oh my God, I never even erased this. Good you all. Had all these examples up there. Nobody even noticed.
No. Yeah.
It looks very good.
Okay, so like this one, and this one, and this one, and this one. These are the operations that are between the number and the x. So this is addition, this is subtraction, this is multiplication because there's nothing between them. This is division, okay? So think of it as between them. That negative 2 up there has nothing to do with the operation. It just has to do with the sign of that number, okay? Keep coming along here. 2-step. And look, it even has a reminder up there. Show all work. All right, so on the front of our paper, we talked about solving 2-step. The first thing I do is I undo the addition or the subtraction. I get rid of the constant first. So looking at number 8, what number is our constant in number 8? 14. Okay, so is that a positive 14 or a negative 14? Positive. So to move it to the other side, I would subtract it, because I've got to make sure that it cancels out. Whatever I do to one side, I'm doing the same to the other side to keep them equal. So ask yourself, 14 minus 14, do those cancel out? Yeah, because 14 minus 14 is 0. So that's 9m equals negative 27. And then step 2 is to undo the addition or the multiplication or division. So what would I do now to get m all the way by itself?
Divide by 9.
Divided by 9. So 9 divided by 9. What is 9 divided by 9?
1.
1. So that's 1m, which is just m. And then negative 27 divided by 9 is negative 3. But I do not want any shortcuts. I need to see all your work. If you're doing this, I will not take that. That is trash. If you write that and then you say the answer is negative 3, absolutely not. That is so elementary, and we are working towards algebra skills. And if you think you're going to solve equations like that in algebra, you have another thing coming. You will get nothing right. Okay, so I am very, very, very specific that it needs to be lined up vertically. Okay, so what I'm showing you up here is exactly what I want to be seeing on your paper. I know there are other ways to do it, like that, but that only works for basic 2-step equations. Next week, we're going to do 3, 4, 5-step. When you go to algebra, there's even bigger ones. Okay, so if you cannot solve them vertically, you will have so many problems. Is that clear to everybody? Well, that's your problem.
How you got that on?
All right, let's look at number 12 here. So number 12, d over 1.6 plus 31 equals 40. So step one, I undo the addition and subtraction first. So what should I do first? Subtract the 31. So 31 minus 31 is 0, which is good. So that leaves me with D over 1.6 equals 9. All right, what operation is this? Division. So the opposite of dividing by 1.6 is multiplying by 1.6. So 1.6 divided by 1.6 is 1, which 1D is just D. And then 9 times 1.6.
14.4.
Okay, 14.4. All right, I want you all to try number 11.
Okay.
Did you show your work like your dad flash fire, or did you show the work like you should?
I showed the work like I should.
Yes, you did. Go Blake. Give me a B. L. A.
Wait, that's
E.
right.
Block it. Block it. Block it.
More like a C copying myself.
Huh?
Copying myself. More like a C for Blake.
We're not talking about a grade.
Well,
All right, so on 11, addition or subtraction is what we undo first. So what should I do first?
At 15.
Subtract the 15.
can I sharpen my pencil?
So 15 minus 15 is gone. So that's 4W equals negative 28. And then what do I do now?
You divide.
Divide by 4 to get W all the way by itself. So 4 divided by 4 is just 1W, which is W. And negative 28 divided by 4 is negative 7.
I got
He did not need the 7 for a
All right.
I forgot.
All right, do number 10. Do number 10. Number 10. All right, so I undo the addition or subtraction first. So what do I do first? Add 16 since it was a minus 16. So minus 16 plus 16 is 0. So let's see, it's 1/2 B equals negative 4 plus 16 is 12. And then how do I get rid of a fractional coefficient? Reciprocal. So what's the reciprocal of 1 over 2? Flip, which is 2 over 1, which is 2. So 2 over 1 times 1/2, they cancel each other out. So that just leaves me with B, and then 12 times 2 is 24. If you got 24 over 1, you should reduce it. I didn't divide.
Like, I kind of subtract.
I went 1.5 times 1. It's like 4.
But you gotta ask yourself, like if you put 1/2 times 1/2, Does that cancel out? No, that gives you 1/4. So that's why you always have to ask yourself, are these true opposites? Is 1/2 times 1/2, do they cancel out? Is a plus 16 minus 16, do they cancel out? You need to put a little bit more thought behind them when you're doing these. You can also check your answers. Okay, so if you were ever on a test or a quiz with this stuff, at this point, if you have time after your test left, you should go back and plug them all in. Okay, so we're just gonna check a couple. We're just gonna do it out loud together, so just participate here. All right, let's check this one. So it's 1/2 times b, but what did I just find b was? Okay, so what's half of 24? And what's 12 minus 16? Bingo, I'm right. Okay, check this one. 4 times w, what did we just say w was? Okay, what's 4 times -7? -28, and what's -28 plus 15? Bingo, up here. 9 times m, what's m? -3, so what's 9 times -3? -27 plus 14. Bingo. They even work with 1 steps. You can check them. Like right here. 9.6, so -6 plus 9.6, that is 3.6. 6 7, so 14, well that's 14 divided by 7, which is 2, 6 times 2 is 12, bingo. And you can use your calculator to check those. You don't have to do them in your head. All right, does anybody have any questions about just being able to solve them straightforward? Okay, so we're just going to do a couple word problems today. They're not bad. I have a process that works for every word problem that you'll ever do. Okay? I've been preaching this to the Math 7 kids because this is what they've been working on for the past month. Okay? Step 1 with a word problem. You read the whole word problem. That's step 1. Step 2, you go back to that last sentence, and if it says how many dogs, you know that dogs is your variable. How many children, children is your variable. How many hours, hour is your variable. Then you go back and you read it again for the second time. When you read it that second time, you're underlining numbers, you're circling operations, and wherever you see dog, children, hours, that's where you're going to put your X. Okay? So on number 14, on a beach trip, Lucy rents a bike from Wheels by Waves, where they rent bikes for $12 plus $3 per hour. If Lucy spent $30, how many hours did she rent a bike? Go to the question. How many what?
Hours.
Hours. So you will always see me do this. And I'll say H is hours or P is hours. I don't care what variable you use. That's the first thing I will do, no matter how easy or hard the word problem is. Okay? Then I go back and now I'm reading it a second time. I'm underlining numbers, I'm circling operational words, and then I'm putting the H where I see the word hours. So on a beach trip, Lucy rents a bike from Wheels by Waves, where they rent bikes for 12. Oh, okay, that's a number. Plus is an operational word, so I'm going to subtract it or circle it. 3 is a number. Her is an operation. Hour. And what did we say hours was? H. If Lucy spent $30. Okay, well obviously plus is plus. What's the word per mean? Multiplication. What are some other words for multiplication? Times, obviously. Product, each, and of. So per, each, of, multiplied, times, product. What are some words for division? Quotient or divided. What are some other words for plus? Sum, add, increase, more. No. There. Some, yeah. Okay, and some words for subtraction. Difference, minus, decrease, less. Okay, so all those are words for subtraction. Okay, so now I can now I can basically just read it and write it. 12 plus 3 times H, so 3H, and they spent, so spent is equals $30. And I'm telling you, every word problem works like that if you use that 3-step process. All right, then I'm going to solve it, so I'm going to subtract the 12. So that's 3H equals 18. Divide by 3, and she rented it for 6 hours.
It's not really.
It's my Audrey. Audrey, glasses make you look like a nerd, so I like one.
Block it.
Yeah.
Your mouth makes you sound hateful, so don't use it. All right, let's do number 15.
Yeah.
15. So remember, like I just said, you read the problem, go to the question, how many what, and that's going to be your variable. Then you read it a second time, underline your numbers, circle your operational words. Wherever your variable is, put it there. Everybody can be trying 15 right now. Do not just sit there and wait for me to do it. I want you to come up with what you can. I'll tell you this, I learned about 70% of the test is word problems. They won't go away, and your all's test is probably going to be about 35–40% word problems on this stuff. So don't just sweep them under the rug. They're not going away. Yep. No. Well, it's not an operation, but it tells you what kind of number it is.
Is this ending?
Oh my God, that was
Descending is like decreasing.
that was
All right, so here's my question. How many what?
Minutes.
Minutes. So that's the first thing you should have done after you read it. Is how many minutes? So I'm going to call M my minutes. So that when I go back and I read the problem again, I'm going to put an M where I see the word minutes. All right, so it says that she's 3.5, or he's 3.5 feet below sea level, descending at a rate of 0.5 feet per minute. If Paul's now at 12 feet below sea level, how many minutes has he been diving? There are 2 ways to set this one up, okay? And that depends on your definition of below sea level. So option 1, my definition of below sea level is that the number is negative, okay? So I would have put her as multiplication, so negative 0.5 per minute, because it's descending, so that means it's going down at a rate of 0.5 per minute. And then he's 3.5 feet below sea level, so that means that that number is negative. And that he is now at 12 feet below, so negative 12. So that's one way. The other way was if you just totally nixed to the below sea level part, you could have put 0.5 m plus 3.5 equals 12. So either one of those is fine, you're gonna get the same answer. So if you interpreted below sea level as negative, then all of them are negative because he's descending, he's below sea level. The other one is still descending at that rate. Okay, he's already gone 3.5 and now he's at 12. So it really doesn't matter there. All right, so I would have done this one, so now I would add my 3.5. So that would be negative 0.5 m equals negative 8.5, right?
Yeah.
And then divide by negative 0.5. And m equals 17 minutes, which you would have gotten either way, whichever one you use.
Look at this, Tony.
Did you get right?
I gotta write to Franklin. All right,
All right, we're gonna go ahead and stop it there.